So we have last time talked about stop and wait protocol, where we get data from the network layer, we construct one frame and we send it. When I say construct a frame, means we are inserting header and trailer. In the header we have MAC addresses, in the trailer it could be CRC. We have discussed last time why acknowledgement, retransmission timer, sequence number and acknowledgement numbers are required even in case of one frame to be transmitted for reliability. Sequence number would be 1 bit in case of stop and wait scenario. 0 or 1, two sequence numbers are sufficient. Now, let us say there is something called negative acknowledgement. So, when the frame is sent, if the frame is correctly received, at that time acknowledgement will be generated. We can have alternative strategy in which we are sending a frame and the frame is found to be problematic. It is having errors. So if the frame is having errors, at that time the receiver can send negative acknowledgement. It is like when I teach you, then we have agreement. There are two strategies. Either we can adapt that after each topic you will tell me that yes, yes. So I know that you are with me. Or if you understand, you will not say anything. But whenever you have doubt, you will interrupt me and you will say that no, this you didn't understand. So I needed to repeat that. So the first one is acknowledgement and the second one is negative acknowledgement. Which strategy is better according to you? Yes, acknowledgement will be fine. In case of negative acknowledgements, we might have some problems in special kind of situations. Like if the frame is received and if it is incorrect, then negative acknowledgement will be sent and then it will be retransmitted by the transmitter. However, if the frame itself is dropped, the frame was traveling, the frame is dropped. So receiver didn't get any frame. So no acknowledgement or negative acknowledgement or nothing can be generated because receiver is not aware about the existence of the frame. So in this case, no negative acknowledgement will be sent. And transmitter is in the illusion that data has been delivered. So here we will have data loss. Similarly, if the data was incorrect and if it was received by the receiver and the negative acknowledgement was constructed, but if the negative acknowledgement itself is dropped, then your transmitter will never come to know that data was problematic and it will go ahead with the next frame. So we have some data losses if you are going for only negative acknowledgement. However, in case of acknowledgement, will be working fine. Is it clear so far? Okay. Then we have discussed this. In the frame structure, we have data, acknowledgement, negative acknowledgement. Which type of frame is that? That we will write in the kind. Then sequence number, acknowledgement number, and information part, which we have received from the upper layer, or let us say network layer. That is how we are constructing a frame. We have a few functions which will be using readily from the header file. Wait for event is a blocked call, which will return event from network layer will be executed at the transmitter to get data from the network layer. To physical layer will be used at the transmitter to give data to the physical layer, to give frame to the physical layer. At the receiver, you will read data from the physical layer and you will give data to the network layer. After sending a frame, we are going to start a timer. If the acknowledgement arrives in time, then timer will be stopped. And increment k is the function which helps us to decide what should be the next sequence number. If the sequence number is 0, it will be 1 next time. If it is 1, it will be 0 next time based on this. So now let us take one very simple scenario which is unrealistic one. We are having unrestricted simplex protocol. Simplex means data flows only in one direction. In duplex, it flows in both the direction. In full duplex, in both the direction, simultaneously data transfer is possible. So when I say simplex, that means data is traveling only in one direction. Transmitter is always a transmitter and receiver is always a receiver. And we are assuming that there is no buffer limits. Your transmitter has infinite buffer, your receiver has infinite buffer, and they have infinite data. We are assuming the transmitter always has data to send, and there is no error. When I say there is no error, that means that whatever data we are sending always will be received correctly by the receiver. In this scenario, do we require acknowledgement? Whenever there is no error, then are acknowledgements required? Why? Why? In general also, we are only using acknowledgements. We don't use negative acknowledgements because negative acknowledgements alone are not sufficient, while acknowledgements ensure reliability. So at the data link layer, in most of the schemes, acknowledgements will be used. So if there is no error, why do you need acknowledgements? What is the purpose of an acknowledgement? To know that data has been correctly received. So whenever there is a doubt that data might be received or data might not be received, then we need acknowledgements. Like let us say, if you are so smart that whenever I say anything, if always you're going to understand that, I don't need to ask you whether you understood that. Because I know that your smartness makes you understand everything I say. Similarly here, if there is no error, then acknowledgements are not required. So again I repeat, the unrealistic assumptions or ideal situation which we are assuming at the moment, utopian, that means ideal protocol is when there is no error, there is infinite buffer, there is no buffer limit, data is infinite, and even the processing power at the receiver and transmitter is infinite. So under this assumption, if we try to write down a transmitter, it would be something like this. While true, while 1, always. Why? Because we have infinite data to be sent. From network layer, read data in the buffer. Now here sequence numbers are also not used because sequence numbers purpose was to discriminate between the duplicate data and the fresh data whenever there is a retransmission. But here there is never going to be a retransmission because there is no error. Whatever you send will be received. So from network layer, we are getting in the buffer the packet. That packet or buffer, we are writing in the information part of the frame. Frame is S, outgoing frame, that is sending frame. So s.info is buffer, and then that S, that is the frame which we have constructed, will be sent to the physical layer. Then again read the next packet and send the frame to the physical layer. Keep doing that quickly without waiting for acknowledgement, without using sequence number, without starting timer, without anything, because the processing speed at the receiver is also infinite. What do you think will be your receiver? You can unmute yourself or you can write what your receiver would look like. Yes, Keval.
Ma'am, in while loop,
Hmm.
ma'am, first will be the from physical layer. The data is
Hmm.
get. Then we assign that data into the buffer and pass to network layer.
Okay. So, will something else be required apart from what you said? You said that from physical layer, read the buffer, read the frame, and then information part of the frame that we can keep to the network layer. So, can you start reading directly? Yes. So, what should you do? When can you read?
When
When can
data
you?
is arrived at physical layer.
Yes, yes. So, for that, what is required? If I directly execute from physical layer, then whatever garbage is present, you might read that. So it will be something like this. Okay. First, you are waiting for an event. It is a blocked call. So whenever event takes place, any event, here there is no timeout because we have not started the timer. The only possible event is frame arrival. Whenever the frame comes, then we are reading frame from the physical layer R that we are putting in the R variable received frame. And information part of the R we are putting to the network layer. Again, we are waiting for the next frame to come. When the next frame arrives, which will be directly, like almost immediately, then this will be out of this. You will read the frame and you will send to the network layer, and this we will do forever. So this is what we do at the transmitter, and this is what we do at the receiver. In case there is no error, infinite buffer, infinite processing speed, and there is no other constraint. Have you all understood this code? So now we are imposing one minor restriction on this. We still continue with the error free channel. Our channel is still error free. That means no acknowledgements, no checksum, no timer, no sequence number will be required. But now we are having the finite processing speed. That means here we are reading and we are sending at the infinite speed as you can, because we are assuming that receiver is processing that immediately within no time. But now our receiver is having finite processing speed. So will this protocol work, or we might need to do some changes? In this protocol there is infinite processing power. Now in the next one we are assuming that receiver is having realistic finite processing speed. So will this transmitter and receiver function in that scenario? Means wait for an event is limited where? You can unmute yourself and please tell me what you are saying.
Ma'am, if we take the realistic situation, then we have like some time that in this time particular time we get information. When time out, then we can switch to the other information.
I don't understand. That means here wait for an event should be there or should not be there.
It should be there, but we can limit this. Means let's
Limit
say
as
in the unrealistic situation, we keep waiting for the message, but in the realistic situation, we can move to the other operations.
no, no. Let us say we are having no operations at the moment. Okay, receiver is a pure receiver which is going to receive it. But the issue is it might be having some limitation, like it can process 1500 bits per second. Or let us say it can process 20,000 bytes per minute, whatever. So parallel processing is not our headache at the moment. What we are worrying about is that when we send the data, will the data be correctly delivered without loss, without duplication, without alteration? That is our worry. So everyone, will this program function when your receiver is not working at the infinite speed? Do you understand the situation which I'm talking about? So try to visualize that if we execute this transmitter in the situation where your receiver has finite processing capacity, will it work or will it not work? That is the question. Exactly, Kaushal. We have to wait at the transmitter until the receiver is done processing the data. Once we know that receiver has done processing this frame, then only I can send the next frame. Once we hear from the receiver that this one is done, then only it will be done. So how do we achieve that? Kaushal, can you suggest me anything, any mechanism that how can we achieve that? Yes, something like acknowledgement. Okay, some signal. Yes, yes, some signal or some acknowledgement or some dummy frame or some sort of feedback your transmitter should be given. Your receiver should be giving that signal to the transmitter. So, can you please also suggest me that what change will be required in the receiver? Currently, we are waiting for frame to arrive. Once the frame arrives, we are reading the frame and information part of the frame we are putting to the network layer. Do we need any changes here? Where? Yes. At which point of time? Yes, at the end. Yes, yes, at the end. In Preet, what do we do in the transmitter? We have get data from the upper layer. We have built a frame. We have sent it. Then what should we do? Then we should wait for the receiver to give us feedback that it is done. Yes, we have to wait for the signal or acknowledgement, something like that. Exactly. So that is our next code. That from the network layer, we are getting our packet in the buffer. We have got something to send. We are constructing the frame in the information part. We are sending that. And now we are waiting for an event. And whenever you're getting out of this, we are not even checking what event is that, because it is not going to be timeout. We have not started the timer. The event will be frame arrival only, acknowledgement arrival or frame arrival, whatever you say, data arrival. So whenever it is there, that means receiver has given us a green signal. Again, you can read the next frame, send it. At the receiver, we are waiting for an event. So whenever you are getting out of this blocked call, then that is frame arrival. So we are reading frame from the physical layer. Information part of the frame, that is packet, is given to the network layer. And then some dummy frame, as we are sending to the physical layer. It is fine if you send the R itself. It is fine if you just send the same frame each time. This two, the content is not important here. Here it is making sure that your transmitter comes out of this blocking call. And then it will be reading the next frame and do. So if your receiver is having finite capacity, then transmitter cannot blindly send like the earlier scenario that read frame, send it, read frame, send it, read frame, send it. That can be done only if your receiver is having infinite capacity. Otherwise, it will have to consider the receiver's feedback. Whenever receiver is done processing and putting data to the upper layer, it will tell the physical layer. It will tell the transmitter via physical layer that I am done. Whenever receiver or transmitter hears that, then only it will send the next frame. So this is what will be required in case of limited processing capacity. Is it okay? All right. So the next code which we are going to see is having realistic situation where data still travels in one direction, simplex protocols, but your channel is unreliable. Your channel is unreliable. That means your channel is a noisy channel which may change the data, which may lose the data. So accordingly we'll have to do. Now hear me for a minute. Actually, when receiver receives a frame, it should calculate whether the frame is correct. Like if it is CRC mechanism, then CRC calculation will be performed. If it is parity, then parity will be performed, or checksum will be verified if it is correct or incorrect. If it is correct, then frame should be given to the network layer and acknowledgement should be generated. If it is incorrect, it should be simply discarded and you should keep waiting for that frame. That is what will be done at the data link layer. But here for our conveniency, we are taking reference of the TCP IP reference model. In the TCP IP reference model, it is said that we have internet layer and below internet layer, we have host to network layer. That means your data link layer and physical layer are combined. So we have passed on this responsibility to verify the checksum to the hardware. That we are assuming that whenever your physical layer is reading the frame, then while reading the frame itself, our hardware is configured in such a way that it will know whether frame is correct or incorrect. So if the frame is correct, then it will tell us frame arrival. If it is incorrect, then it will give us checksum error. So what are we doing here? We are passing on burden from the data link layer to physical layer for conveniency to understand this program. It will not happen in the real life. Just in this program, we are assuming that the hardware is smart enough to judge whether the frame is correct or incorrect. Correct as in whether the frame is not changed, the data integrity is maintained. If data is integral, then it will be sending you frame arrival. If data is tempered or if data is not correct, then it will be giving you checksum error. So when you are waiting for an event, then the event itself will be frame arrival. Frame arrival means correct frame has come. Checksum error means frame is problematic. And timeout means you have started a timer and the timer goes off. Now please understand that when I say frame arrival is coming, that means the content of the frame is not changed. However, that does not mean that that is the desired frame. Like you have received frame number 1, you have generated acknowledgement of frame number 1, and now we are waiting for frame number 2. But if the acknowledgement was dropped, then transmitter again will be sending you frame number 1. So in this scenario, the event will be frame arrival only because of frame content, the data is correct. So you will check that, oh, this is frame number 1 and I was looking for frame number 2. So you will discard the frame and acknowledgement will be sent. So I'm telling you that the difference between these two, like if you send some data 11001, then if the data is coming 11001, then it will be frame arrival. If the data is changed, then it will be checksum error. Are we on the same page? Okay, let us see this program then. Try to pay attention. So this is go back and protocol where there is one buffer at the transmitter and one buffer at the receiver. Transmitter we require a buffer because you sent a frame and now you have started the timer. So if the acknowledgement arrives, then fine, data has been delivered. But if acknowledgement does not come, then you may need to resend the frame. So that frame has to be present at the data link layer. So you are storing that in the buffer. At the receiver, one buffer is required because when you receive the entire frame, then only you can calculate the checksum. So first you will have to store the bit string entire frame in the buffer. Once you have it, then you can perform the operation and see whether it is correct or not. So one buffer is required at the transmitter, one frame worth buffer is required at the receiver in case of stop and wait protocol. In the next protocol, in the transmitter, there are multiple buffers, and at the receiver, there is only one buffer. In the next to next protocol, we have multiple buffers at the transmitter and multiple buffers at the receiver. So of course, complexity will be much higher in that scenario, and it will be sophisticated and smart protocol, which is actually used in the real life. However, in order to reach there, we have to begin from the beginning and go incrementally advanced stage. So pay attention here. If you fail to understand this, I'm not sure whether you will be able to understand the next one. So if you have any doubt, you can ask me. But at that point of time, if you ask me doubt after in the next class or next to next class, then I might not be able to come here and again explain you from the beginning. So everyone, please try to pay attention. So at the sender, now I said that I have errors or I have noisy channel. The moment we have errors, we require sequence numbers, we require timer, we require retransmissions. So next frame to send is a variable which is sequence number of the frame which we are sending. Frame, packet, event. We are initializing next frame to send is 0. So first from the network layer, we are reading first content, first frame is read. So let us say data 1. Okay, we are sending data 1. The first frame is data 1. So data 1 is in the information part. Sequence number is next frame to send. Next frame to send is 0. So sequence number will be 0. So the frame which we have constructed is 0, data 1. We are sending that frame to the physical layer. And then we are starting timer for frame number 0. And now we are waiting for an event. We have read data from the network layer, constructed a frame, sent a frame, started a timer, and then we are waiting for an event. Now, if the event is frame arrival, that means the frame is intact. Then we are reading frame from the physical layer. We are checking, is acknowledgement same as next frame to send? Like next frame to send is 0. So are we getting acknowledgement of 0? If it is the correct acknowledgement, then stop timer. We are stopping the timer. And from network layer, we are getting next data. So in buffer, now we have data 1. And increment next frame to send. So if next frame to send is also 1. Sorry, data 2. Now the next data 2 and frame number 1. This will come here. Data 2 will be written in the information part, 1 in the sequence number. So now we are sending frame 1, data 2 to the physical layer. We are starting the timer. We are waiting for an event. If event is frame arrival, then we are reading from the physical layer. We are checking the acknowledgement. Is acknowledgement of 1? If yes, then we are stopping timer. We are getting next data 3 from the network layer, and frame is incremented again to 0. We are having maximum sequence number defined here as 1. So it will toggle between 0, 1, 0, 1, and again will send the next frame. So this if it was frame arrival. If it was not frame arrival, if the event was timeout, then what will happen? So look carefully, this part will be skipped. If the event is not frame arrival, then this part will be skipped. And the buffer content as well as the next frame to send were not changed. They are the same as old data. So old data, you are retransmitting and starting the timer. If it is checksum error, that means you are getting a frame but the frame is not correct. Then what will you do? You will not stop the timer. You will not read the next frame from the network layer. You will not update the variable, but the same frame will be resent. If you send frame number 0 and if you are getting acknowledgement of 1, then acknowledgement number will not match with this. So we will not stop the timer and we will not read the next frame. We will simply skip here and again we'll wait for an event. So have you understood the transmitter? Or noisy channel. If you have any doubt, feel free to ask me. In this code, if you have any doubt, ask me. Which part, Keval? That cannot be briefly. Whichever part you have not understood, tell me that. Or you can do one thing. While loop is the program. Go through this, everyone. Okay. Assign the values, go through this, and if you have any doubt, then ask me. Take 2 minutes. Everyone pay attention here, and then we will discuss the receiver. Yes. So see, if it is checksum error, then what will happen? This part will be skipped and retransmission will be taking place. The same frame which you have sent, that will be repeated, because here it will think that probably acknowledgement was coming, but acknowledgement is garbled, so we don't know whether that was correct acknowledgement or incorrect acknowledgement. So to be on the safer side, it will be retransmitting the frame. In retransmitting the frame, our reliability will not be compromised, because if receiver has already received it, then receiver will discard that and you will get an acknowledgement next time. Because let us say you have sent frame number 0, receiver has sent you acknowledgement 0, but that acknowledgement 0 is somehow changed, then you will not get into this. Then you will be again sending the frame. So we can say that checksum error is acting as negative acknowledgement in this scenario. Does that statement make sense, Pavik? Checksum error is triggering a retransmission. It is acting as negative acknowledgement. Others? See, when I say go through this, you should go through this. And this is fairly simple if you are just attentive and focused. Because here we have sent, say, if you remember, we said that we'll be sending frame number 0, then we will send frame number 1, then 0 and 1 and so on. First frame will be having sequence number 0, second will be having 1, third will be having 0. Were you present yesterday, Harsh? I mean, in the last class? Okay. So, we need sequence number to be able to differentiate between this. So, to achieve this sequence number range, we are going to increment it, or let us say invert in this scenario, because there are only 2 sequence numbers. So this was the transmitter. Now, can anyone unmute self and tell me roughly what your receiver would look like? And let us make it real fast. And that is okay if you don't get the entirely correct code, because had you known that, we would not be discussing this. So that is okay if you cannot come up with the 100% correct answer. However, I believe that now you should be at the position to at least logically think some part of the flow. Keval, did you understand the while loop? Okay. So I'll wait for a few seconds. If any one of you would like to uh, tell me the steps at the receiver. If you can't, then we'll discuss it. No problem. Yes, Keval, please.
Ma'am, am I audible?
Yes.
Ma'am, in the while loop, first we should be waiting for an event. Means like the first is the
Yes.
wait for the event. Then
Hmm.
once the event we got, then we need to check that if the valid frame is arrived or not. Means the checksum and that. Then once it is
See,
means
wait,
the
I'll interrupt you here. We will
yes
not verify the checksum, because when frame arrival is there, that means checksum is correct. If it is incorrect, then you will have checksum error. So if it is
okay.
frame arrival, you will read it, but you will check the sequence number. Is sequence number what you are expecting?
Yes, ma'am. Yes, ma'am. That was I was
Hmm.
telling. Ma'am,
Yes.
once we check that frame arrival is happen, like in this, we are checking in like in the if statement.
Hmm.
Then we pass to the then we get data from the physical layer. Then
Yes.
once the getting data from the physical layer, we are checking that the sequence number is
Hmm.
what is we are expecting, that
Hmm.
is the same or not. Then if it is the same, then we pass it to the network layer.
Yes. Then
Then yes, once the data is get to the network layer, then I think we should also need to send acknowledgement to the transmitter through
true.
physical layer.
Yes. And
Yes, I think, ma'am, it is.
okay. So that is the broad flow. Now let us see here. This is what we will do at the receiver. At the receiver, we are having the variable which we are naming as frame expected. At the transmitter, we had next frame to send. At the receiver, we have frame expected. Like which frame are we expecting? So initially, we are expecting frame number 0. Why? Because transmitter is going to send frame number 0. So both of them should be in sync. If your receiver expects 1, then it is never going to get 1 first. So both of them should be starting with 0 or 1. Usually it is the standard practice to start with the first sequence number, which is 0. So frame expected is 0. Then in the while loop, because still we have infinite data, or we are waiting for an event. If the event is frame arrival, then from physical layer, read the frame. In the received buffer, read the frame. Check sequence number. Is sequence number same as what you are expecting? Like, is sequence number 0? If yes, then pass on information part of the frame to the network layer and expect the next frame. So we are expecting the we are incrementing the sequence number of frame expected. So now frame expected will be 1. We have passed on data 1 to the upper layer, and now your frame expected is 1. Acknowledgement is 1 minus frame expected, which was incremented to 1. 1 minus 1, 0. So we are sending acknowledgement of 0 to the physical layer. We have received 0. We are sending acknowledgement of 0 to the physical layer. Again, we are waiting for an event. So next frame arrival, you are reading the frame. Next frame is, let us say, 1, data 2. the first was 0 data 1, now it is 1 data 2. So you are checking, is it 1? Yes. Then put information part, which is data 2, to the network layer. Again, increment frame expected. So now expect frame number 0. Acknowledgement is 1 minus 0. That means acknowledgement of 1 is sent to the physical layer. Again, we are waiting. So if the event is frame arrival, this is what we will do. Here there is no possibility of timeout because we have never started the timer. If the event is not frame arrival, that means it is the checksum error. So if the event is checksum error, then this will be skipped. And again we will keep waiting. If the frame is incorrect, then we are not even going to read that. We are not going to bother to read the frame because the frame is incorrect. So simply discard it, ignore it, and keep waiting for the event when you have the correct frame. Now let us say we have received first 0 frame. So we have sent to the upper layer. Now we are waiting for frame number 1. An acknowledgement was sent. But if acknowledgement is dropped, then what will your transmitter do? Yes, it will retransmit. So here we are waiting for frame number 1 now. So retransmitted frame is coming here. However, we will not know. It will not be written that it is a retransmission. It will not be written like that. So you are having frame arrival. We are reading from the physical layer. The sequence number in this frame is 0, but we are expecting 1. So this does not match. So we are not going to put that data to the upper layer, and we are not going to expect the next frame. We will still continue expecting frame number 1 only. So this 2 lines will not be executed. Will directly come here. Acknowledgement of 1 minus 1. That means 0 you are going to send. So if you are getting 0 frame again, then you are going to generate the acknowledgement. However, data will not be given 2 times to the upper layer. So I think it works just fine. If you understood this, let me know. If you haven't, pay attention here for 1 minute. Look at this, try to absorb it, and then let me know. So does this make sense to you? That your retransmission are handled properly here? Checksum error is there, then we are not reading the wrong frames. If the frame is what you are expecting, then only we are passing on data to the upper layer and we expect the next frame. And along with that, acknowledgements are also sent. So even though this is the small code, it should work just fine. Have you understood this? Okay, so now anyone, if you have any doubt in this receiver, let me know. So this is the sender in case of errors, and this is the receiver. Have you understood them, or do you have any doubts in this? I'll not be able to accommodate on the same page. If you understood this, then we'll be moving on to the next stage. If you have any doubt, you can ask me. So I understand that you have no doubt. So far, the assumption which we have made is simplex protocol. Other things are fine. That now we have limited processing speed, we have errors, everything. So we have tuned our protocol according to the environmental changes which would be there in the real life as well. However, when we are talking about the actual communication in the networking, then there are many conditions where we will need to go for bidirectional communication. Like when you are surfing something, then you are writing a query to Google server, then you are the transmitter and Google server is the receiver. And when Google is responding to you, then it is a transmitter and you are the receiver. What I want to convey is it will not happen that one computer is a pure sender and one computer is a pure receiver. In the realistic situation, both of them are going to act as transmitter and receiver either at one point of time or at some point of time. Like currently I'm the transmitter, after some time I'll be the receiver. And the same at the other part. Do you agree with that? That means this type of program, there is one program for the sender and one program for the receiver, is not something which will be used in the real life. We might need something more than this. So let us try to understand the situation. Okay. Let me write it here. Okay. So we are deciding our frame structure to be like this. In the frame structure, we have sequence number, then we have acknowledgement number, and then we have data. Why so? Because we are having, let us say, two hosts, A and B. A and B are two parties who are talking to each other. I'm not using the word now transmitter and receiver because A is transmitter and receiver both. B is also transmitter and receiver both. So A is sending the first frame. The first frame which it is sending is A0, let us say. Sequence number is A0 and data is A0. B is receiving that. When B receives that, what will B do? B will send an acknowledgement of 0. Now let us say B also has to send reply to the query which A has received. So B will be constructing the first frame A, B0. Now this acknowledgement which was generated, A has received that. So what will A do? A might send the next frame 1, A1, which will be received here. And A is also receiving the frame or the reply. Reply, when you say that, means it is frame only. Question is also a frame, reply is also a frame, acknowledgements are also frames. So this frame is received at the A now. So when A receives this frame, it is correct. So what will A do? A will send an acknowledgement that take the acknowledgement of 0. Now let me write it here. Okay, the acknowledgement of 0 that will be sent by A. Now B is receiving this. When B receives this, what will B do? This is received by B. So B will have to send acknowledgement of that. So B will send acknowledgement of 1 to A. Now B is receiving acknowledgement of the frame which it has sent. It has sent 0B0 and it is getting the acknowledgement of that. So it will be happy that okay, I have sent frame number 0 that has been delivered. So what it will be doing now? It will be sending the next frame. It will be sending this. Are you with me? Yes. So here we are generating separate frame from the acknowledgement and data frame. So rather than that, if we used this frame structure where sequence number, acknowledgement number and data frame are together, which was not required here. Here we didn't do it. Here we just sent the frame in which there was sequence number information part, two things only, never the acknowledgement, because this was the pure transmitter and this was the pure receiver. But here we are having trans receiver at both the ends. So rather than sending these frames individually, it is only wise to combine them. Why? Because when you send them individually, at that time this will be having the header, this will also be having the header, and processing of this will be done separately. This will be having the header, this will be having the header, processing will be done separately. So it is expensive. So rather than when you are sending the first frame, we are going to stuck to this. So currently we don't know what we should write in the acknowledgement. So I'm not talking about that at the moment. When B receives it, what should B do? B can generate a frame. Rather than sending this to, B can send something like this. B can send that, okay, I also want to send one frame. Sequence number is 0 because that is the first frame. I have received 0 frame from the transmitter. So I should send acknowledgement of 0 and my data is B0. Rather than sending 2 frames here, 0, 0, B0, it has sent this frame. When I is receiving this frame, then it says that okay, I have sent 0, I have received acknowledgement of 0, so everything is fine. So A will be constructing the next frame. Can you tell me what will be the next frame? Sequence number should be 1, acknowledgement what acknowledgement should A give to B? 0. True, because it is receiving 0 frame number from B. So acknowledgement should be 0. And next data, let us say data is A1 now, that you are sending to B. In response to this, can you tell me what frame will be constructed by B? Yes, it will be 1, 1, B1. It has sent 0. It has received acknowledgement of 0. So you can send the next frame 1. It is getting 1 frame. So acknowledgement of 1 is sent. And data is next, which is B1. Now the last one. Can anyone else please tell me what will be the next frame generated by A in response to this? Zero frame number, because 1 was sent, 1 has been acknowledged. So now we are sending frame number 0. And now I have received frame number 1. So I should need to give acknowledgement of 1 and data is A2. And so on. Have you all understood this? If you have any doubt, feel free to ask me. How many of you understood this? So this process is known as piggybacking, where rather than sending two frames separately, A and B, I mean not A and B, sorry, data frames and acknowledgements, rather than sending them separately, if we can combine them, then we can say that acknowledgement is getting the free ride with the data frame and our efficiency will be improved. So this concept is known as piggybacking. And in the real life scenario, whenever we have bidirectional communication, then always we'll be having something like piggybacking. So if it is clear, then I would like to ask the next question. The question is, here we, okay, first, what should I write in the question mark? Like when you are sending the first frame, then if I decide that the frame structure is going to be like this only, then I cannot skip that, okay, I don't have anything to acknowledge, so I'll not write it. We cannot do it. All the fields must be written. Sequence number, then acknowledgement number, and then data. Now here, there are only two choices actually, if you think over that. There is sequence number 0 and there is sequence number 1. So in the first frame, where it is not actually sending acknowledgement of anything, should we write 0 or 1? Yes, we should write 1 and not 0. Because if you write 0 here, then receiver will confuse that acknowledgement with the data which it is about to send. Because the first frame which B will be sending will be having sequence number 0. And if you are already sending acknowledgement of 0, it might think that, oh, I have received the acknowledgement of 0, so I should be sending frame number 1. However, if it receives the 1, then either it will think that, okay, but I have not sent anything, so this could be a random acknowledgement. Or it might think that, okay, but I'm going to send 0 only, so this 1, whatever way it wants to interpret, it will not harm that. So the first acknowledgement should be the one which other party is not going to send you. If you are sending in the acknowledgement what the other party has just sent, then you will be in problem. Like let us say this has generated this frame. Similarly, B also had something to send. So B has also sent this frame already. And now if instead of 1, if you are sending acknowledgement of 0, then B will think that this frame has been delivered. And however, this frame might not be actually delivered. It might be lost. Are you with me? Okay. So one more question and then we will stop it. Like here, we said that A is sending the first frame as sequence number, acknowledgement and data. B is receiving that. B is also having data to send. So it will be sending sequence number, then acknowledgement number and then data and so on. But now it will not happen that A and B always have data on hand when it is getting data from the other party. Or it may not happen that both of them are having exactly same amount of data. One might be having, let us say, when you are sending something, the other party may not have data at the moment because application is not generated that. So it was not given to the transport layer and it was not given to the network layer. And hence data link layer is having no data to send. So let us say this data is received by B. If B is having no data to send, then B cannot actually wait for data to arrive and then only it will be sending this frame. Because if it does it, we will have a problem. What will be the problem? Please maintain your focus for 2 more minutes. Then we are going to stop it. Again, I repeat the question. A and B, here what we have assumed that when A is sending the data, B is always having the data. So B will construct this frame. When it is received here, then A is also having the data. So it will construct this frame. When it is received here, B is also having the data. So it will construct this frame and so on. So we have conveniently assumed here that always data is available at both the ends. While that is not the realistic assumption. Do you agree with that? So sometimes that may happen that A has sent this data. Okay, A has sent this data, B has received it. But now B is not having any data at the moment. B is not having any data at the moment. Then if B waits for data, to get from the network layer, then that is not a very convenient situation because it will lead to some problem. Can you speculate what problem would it cause? After sending this frame A, what will A do? It is waiting for an acknowledgement. Yes, A is waiting for an acknowledgement. And if we don't provide acknowledgement to A, then what will happen at A? Timeout. And it will retransmit the data. No deadlock. There will be a timeout. And it will retransmit the data. So that means here the retransmission is caused because B did not generate the acknowledgement. And why did B not generate the acknowledgement? Because it did not have any data to send. Certainly it is not something fair. So what is recommended at B? That whenever you are receiving any frame, if you have data, fine. You combine acknowledgement and data together and send it. If you don't have any data at the moment, then start one timer. Name of the timer is acknowledgement timer or auxiliary timer. I am not writing it. Whenever B is receiving any data from A, then if it is having data, then it will be sending data and acknowledgement on the spot. But if it is not having that, then small time duration, it will start the timer, acknowledgement timer, or it is known as auxiliary timer. It will wait for data to come only for that amount of time. If data does not come by that time, that means now it is high time that it has to send acknowledgement alone. Because if it doesn't send it, then your receiver, your transmitter, I mean the other party, other party will have a phase timeout and unnecessary retransmission will be caused. So separate acknowledgement will be issued whenever acknowledgement timer goes off. Which timer do you think will be having the higher value, acknowledgement timer or retransmission timer? Retransmission timer is triggered whenever acknowledgement has not come and you suspect that data has been dropped or data has been incorrectly delivered. Acknowledgement timer goes off so that now it is the high time that we have to send the acknowledgement alone. Otherwise, your transmitter will face timeout. The question which I am asking is, we are having two timers now. One timer is the transmitter, that is retransmission timer. Other timer at the receiver, which is acknowledgement timer. This is in case of bidirectional data communication. In unidirectional data communication, we don't have acknowledgement timer. So which value do you think will be larger? Will acknowledgement timer is of the larger duration or retransmission timer is of the larger duration? So this makes me ask the question, have you understood what acknowledgement timer is? Yes, of course, retransmission timer. So roughly, I can say that retransmission timeout duration will be forward delay plus reverse delay plus processing delay at the receiver plus acknowledgement timer's delay. That is what your retransmission timer would be configured like. Okay, so I request you to read this piggybacking from the textbook along with auxiliary timer or this timer. It is given in the textbook that this is what we want to generate. And next time we are going to write the code for this. So come prepared, understanding at least the behavior of this, and then we will look at the code and we'll move to the next protocol. Thank you.